8.2 says if it is further given that f of x, which is the original equation, is equal to minus x cubed plus x squared plus x plus 2. So I'll rewrite that if it isn't clear on the image. Eight point two point one says determine the coordinates of the turning points of f. So in the previous question, we were dealing with the first derivative of f, which had, let me try to draw that meter, which had two roots. And if we know anything about the first derivative of a function, is that it describes the rate at which its gradient is changing. So this first derivative function that we had represented the gradient of our original cubic function, which is this one. So if we want the turning points of this cubic function, which probably looks something like this or like that, we have to figure out these points over here. So what are the x values for which their gradients are equal to 0? Because at the turning points, the gradient is stationary or equal to 0. So we basically look at our function that we had in the previous question. We saw that it was 0 when x was minus 1 over 3 or when x was equal to 1. So we can find the values of y that correspond to these values of x by plugging in these values into the original equation. So minus 1 over 3, this is cubed, plus minus 1 over 3 squared, plus 1 over 3 plus 2, all on your calculator would give you 49 over 27. Then this would be for one of the turning points, so this would be for minus 1 over 3 and 49 over 27. Then the second coordinate, you would do the same thing, but instead of finding it for minus 1 over 3, you do it for 1. So if x is equals to 1, we have minus 1 cubed plus 1 squared plus 1 plus 2. So this one and that one can cancel. We'll be left with 3. The second turning point would be 1 plus 2, 3.